Okay, so on lesson 2.4, we take this inequality game to the next level by introducing multi-step inequalities and how we solve those. And, I think you're starting to get the hang of this because I say it almost every lesson here in chapter 2 with inequalities. The majority of our steps are going to be just like what we did with equations. So when we say multi-step inequalities, we're really talking about the same multiple steps that we might have to do with an equation. And those, to review, are the following. First, simplify each side, right? So we had already talked about that. This is just reviewing what it means to be, to have to work multi-step inequalities. So we simplify both sides of the symbol. So we look at each side individually, each expression, and we make sure that there are no grouping symbols, that there are no like terms, and that that side of the inequality is as simple as possible, that there's no math that we can do to that particular expression. Okay. Step 2, if necessary, gather the variables to one side. And just that comes up when you have variables in both expressions on both sides of the inequality. We'll want to pick one, do the opposite sign, and move it over so that all your variables are on the same side of the inequality symbol. And then, and only then, do we use those inverse operations to isolate the variable and solve. Okay, that's the third step, but only after we've done these other things. So, to kind of bring that together, to solve a multi-step inequality, we simplify each side of the inequality if necessary. Then we'll use inverse operations to isolate the variable. And you want to be sure, this is the one place that this is really the big difference between equations and inequalities. We want to make sure that we reverse or flip the inequality symbol when we end up multiplying or dividing by a negative. That's what we talked about in the last lesson, and that's really the biggie that you want to remember that is different in this particular unit. Okay, so let's go ahead and put these in practice. If we go through our little check sheet, first things first, kind of look at each side independently and just make sure that it is simplified. So 3x minus 2, that is fully simplified. There's no like terms, there's no grouping symbols, there's nothing I can really, no math that I can do to make that any simpler. Same thing on the other side, it's just a 10, so nothing I can do there. So then we'll check to see, okay, are there variables on both sides? Do I need to fix that? Well, not in this case, right? X's are only on the left. I don't have any X terms on the right. So second step is, okay and taken care of. So we can go ahead and start with the solving. And this does have two operations, right? This is the other difference here. We had only dealt with single operation inequalities until now. But this does have two operations. They multiplied by 3 and they subtracted 2. So I need to undo both of those, and like we talked before, we're going to do that in reverse. So we're going to start off by doing the inverse operation of that subtraction of the 2, or that combining with the negative 2 by doing a positive 2 on both sides. We'll start by eliminating that. Unless there's a grouping symbol, that's usually where you're going to start. You're going to start with the addition and subtraction, then you'll go to the multiplication and division. So we do a positive 2 on both sides. Now we've got a 12. And then there's round 2 of this, which is then go back in and do the next inverse operation to undo this multiplying by 3. The opposite of that is to divide by 3. And that cancels this. And then we really do have x isolated. X is less than 12 divided by 3. We know is 4. I don't have to flip any inequalities or anything because these were positive 3's. So my solution set is all the x's that are less than 4. Okay? And now we can do some graphing here. I'm going to just do some quick labeling here, as long as you have a good sense of, boundary numbers, above and below. Then we can find that boundary number 4. We're going to leave this circle open because it's not or equal to. And we want all the x's less than, so we know those are the ones on the left side of the number line. So there would be our graph. Okay, let's try number 2. check to make sure both sides are simplified and that you don't have variables on both sides. Both of those are okay, so we'll get started. We'll start off by eliminating the addition or subtraction first. That leaves us with 4a is greater than or equal, and on this side 0 and -8 is -8. And then in the second round here, we'll go back in and do the second step of elimination, eliminating that 4. So if I'm multiplying by 4, the opposite is to divide by 4 on both sides. So we get a is still greater than or equal to a -2. Okay, and these are positive 4s we divided by, so we don't have to worry about any reversal of the inequality symbol. We're okay here. And then we graph our solution. So -2, -4. In this case, sorry, I'm going to have a boundary number at -2, and it is going to be a closed circle because it does include the 2. I want all the a's that are greater than. That's numbers live to the right side of the number line, so that would be what my graph might look like. Okay, let's take a look at number 3. On number 3, we are going to check to make sure it's simplified, right? We're doing b divided by -3 plus 2, and on the other side it's just a 3. So no like terms, no grouping symbols. We don't have b's on both sides, so we're still okay. We'll start off by eliminating the addition or subtraction, so we'll get rid of this +2 with a -2 on both sides. And that leaves me with b divided by -3 is less than or equal. And on the other side, when I combine a 3 and a -2, signs are different, so I find the difference and I just get a 1. And then we do the second round of elimination here. So to get b alone, I also need to undo this division. The opposite of dividing by a -3 is to multiply by a -3 on both sides. Okay, and that gets rid of the division. However, ding, 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 hopefully your spidey senses are already tingling here, because if we multiply by a negative on both sides, I really want y'all to remember you have to now flip your inequality symbol. So instead of less than, this time it's now going to be greater than here. If you multiply or divide by a negative on both sides, you have to flip your inequality symbol. Reverse the direction that it's opening. So now it's going to be the b's that are greater than or equal to, and on the other side, 1 times -3 is still -3. So our solution is all the b values greater than or equal to -3. So just don't forget to flip that sign if you multiply or divide by a negative. The rest of it is, well, mostly review. So, okay, so here's 0, 1, -1, -2, -3, -4, 1, 2, 3, 4. Our boundary number is going to be at -3. Should be a closed circle here because it does include it, and I want all the b's that are greater, so those b's are going to be on this side. Okay? All right, let's try the next one. Step 1, simplify both sides. Oh, look at there. This is when we start to see those more complex types of problems. This has a grouping symbol. So I want to distribute this -4 and clean this up before I begin any type of inverse operation. So for just a minute, I'm going to leave this alone, and I'm going to focus on distributing that -4 to the parentheses. So -4 times d is a -4d. And a -4 times a +1 is still a -4. Okay? And then I confirm that that is as simplified as I'm going to get it, that there's no d's on both sides. And now I can start to solve for d. So I'll start with the addition subtraction. I'm going to add 4 on both sides, or do a +4. So I get 12 is less than or equal to, and on this side it's a -4d. Okay, round 2 is to get rid of the -4. They're multiplying by a -4, so I have to divide by a -4 on both sides. This cancels. Okay, so now I have 12 divided by a -4 is -3. But oh, that's right, I divided by a negative on both sides, so now I have to reverse that inequality symbol. It's going to flip the other direction, so that's the biggie. So -3 is now greater than or equal to, and then d on the other side. And that is my solution, but we've talked about how that's pretty hard to read and often causes problems graphing. So I'm going to then really highly recommend, beg, implore that you take that whole statement and you rotate it so it's easier to read. So D is less than or equal to -3. This is different than flipping just the inequality. It's rotating the entire statement, so it's not changing the relationship. Okay, so this is really where my solution set lies. It's all the D's that are less than -3. So all I have to do now is identify where -3 is located on my number line. And this is going to be a closed circle on -3. And everything that is less than or equal to that, so that's the values over here on the left. Okay. All right, so just a little bit of review of marrying that multi-step process with the inequality relationships, okay? Now, before we get into the ones that actually have variables on both sides, that really brings us to those special cases. So when we had equations that have variables on both sides, we realized that sometimes we had a special situation that either had all real solutions or, no solutions at all. Well, the same can start to creep up for us in inequalities, okay? If you end up, when you're solving and you simplify both sides, okay, if you obtain two equivalent inequalities, basically if you get two matching inequalities where both sides are exactly the same, the variable terms are the same, and you get a true statement like -5 is less than 0, well, that's true. Then we know that the solutions for that are real solutions. Okay, and if your variables cancel out, if you get matching or identical variables and they cancel out, but then the leftover inequality is false, like 3 is less than or equal to -2, we know that doesn't make sense and it's not true, then it's a no solution. And you'll see these in action in just a moment. Okay, and when we graph them, it's pretty straightforward. If it's all real numbers or all real solutions, then you're going to essentially shade the entire number line in both directions. And if it has no solution, you are going to leave your number line empty. Okay, so for all real numbers, you'll basically shade in both directions, both arrows, the whole line. And if it's a no solution, you're going to leave it empty. Okay, so let's practice a few that are like that. Okay, so if you look at number 6, for example, bring this down. On number 6, we have 6h minus 18 is less than 6h plus 1. I checked to make sure both sides are simplified, and they are. There's no grouping symbol, there's no like terms, there's no grouping symbol, no like terms. Step 2 is to check to see if I have variables on both sides. I do this time, right? But in fact, if I'm paying close attention, not only do I have them on both sides, but they are identical. That is already my big hint that this is going to be a special case, okay? Because what my next move normally would be, like we said over here on the other side, would be to gather the variables on one side. So that would mean, I'm going to pick one of these, I'm going to do the inverse sign so that I can get rid of them. But in order to do that on one side, I just have to make sure I do it on the other side. The predicament is that in my effort to cancel these, I inevitably cancel both sides because they are the same. Okay? Well, that's not the end of the world. That's just a big hint that we have a special case, right? But what really is important is to see what's left behind when my h values cancel. So when I decide I'm going to remove 6 h's from this side, and which means I have to remove 6 h's on the other side, and I realize at that point, oh, well, that means I don't have any h's anymore. I just have the statement -18 is less than 1. That's all I'm left with now, okay? The question is that true? Does that make sense? Is -18 less than 1? Well, yes, it is. That means that this inequality has a solution set that is all real numbers, okay? There it is, okay? Let's try number 7. So on number 7, I check to make sure both sides are simplified. No grouping symbol, no like terms, okay? And then in the next step, I notice I have variables on both sides, so I want to gather them. These are not identical. So that means that this should not be a special case. It should just be solvable. I should be able to eliminate the p's from one side, but still have them on the other, right? So in my effort to get rid of these, that's totally fine. On the other side, I end up with 7p. So this is solvable. I still have a p term. I'll be able to take this all the way home and get a solution set by isolating that. So they're not identical. If they're not identical, then it's going to work out like a normal, regular problem. So I'm going to do positive 4p, positive 4p. 7p plus 4p is 7p. So I have 7p's now on this side, and they're completely gone from the right side. So I have 7p, I still have that plus 4. That is greater than or equal to 25. And see, now it's just a regular two-step inequality where I can get this p by itself by undoing these two operations. So I'll take away the 4. I'll get 7p is greater than or equal. On this side, 25 minus 4 is 21. And then in this second round of solving, I will undo this 7. The opposite of multiplying is to divide by 7. And that cancels this. So I get that p is greater than or equal to 21 divided by 7, which is just 3. So see, this is just a regular normal problem because after simplifying, I had p-values on both sides, but they were not perfect matches. So they didn't cancel each other out like they did in number 6. Okay? But look at number 8, right? So on number 8, when I do my first step, which is simplifying, I notice, I have a couple of like terms right in here. So on this left side, on that same side, I've got two terms that are like terms that I can combine together and write more simply. So on the same side of the inequality, I have 7j's minus 4j's. And I'm thinking, well, I can write that a lot simpler. I just really have just 3j's. There it is. Right? So I have 3j's with the 6. And that is less than. And now on the other side, I have negative 2 plus 3j. Now, we might not have seen it at the beginning, but now that I've simplified, I'm going to start to catch on, oh, there it is. These guys are identical. Okay? And when I go to that next step of gathering the variables, like we did over here, where I moved the 4p and got rid of them on the right and then, got a new value on the left, when I go to do that here, because these are identical, it's going to cancel both. And I'm not going to have any j's left. Well, that's okay because we were already expecting a special case. But look at what's left because that's what's going to determine our answer. The statement that I have left behind when my j's go away, when they disappear, I'm left with the statement that 6 is less than negative 2. And we all know that that is incorrect. That is not a true statement. Okay? Which means this has no solutions. There's no solution here that will ever make this true. So this has no solution. So you can see what that looks like compared to these guys and also compared to one that does have solutions. Okay, let's try one more. So on this one, definitely lots of simplification. I can see those grouping symbols right away. I want to clean those up. So right now I'm just simplifying each side separately. So I'm going to distribute the 12. 12 times a fourth is 3, so I get 3w. 12 times 3 is 36. So that's what I get in that left side expression when I distribute the 12 to get rid of the parentheses. On the right side, I distribute the 3, and I get, the symbol still there, I get 3 times w is 3w, and 3 times a negative 4 is a negative 12. Okay, after this simplifying, I might start to realize, oh look, these are a match. And in my next step that I normally would do, which is to eliminate one of those variable terms, I realize I can't really eliminate one without eliminating both because they're identical. And I now have just 36 is less than or equal to negative 12. Is that true? Is positive 36 less than or equal to negative 12? No, that's not true. So this also has no solution. Okay. So that has reviewed the different steps for multi-step. So always simplify first, gather your variables, then solve. Solve in the reverse order that PEMDAS would simplify. And then if your variables match and they eliminate each other, then really it's about reading that last statement to decide which of the special cases it's going to be. Okay? All right, now I have great news for you guys. We are not going to do 10 or 11. We meant to take this off our notes. We're not worrying about those, so we're going to jump down and finish out with just a couple of word problems, and we'll be done. So check out number 12. Okay, the area of the rectangle is greater than 60 square feet. We want to write and solve an inequality to find the possible values of x. So what I know here is that the area for this particular rectangle is greater than 60 square feet. Okay? And it's a rectangle, so what's really going to help us right off the bat is remembering what the formula is, because that's probably what I'll use. Is the formula for area is what I'll use to set something up here that will help me solve. Okay, so I know that, just as a side note, area of a rectangle is always the length times the width. Okay, so if I do the product of the length times the width here, I have a length of 12 feet times the width of 2x minus 3. I know that product of length and width will give me the area. So this represents the area of our rectangle. We know that area needs to be greater than 60. And there's my inequality. So the product of length times width needs to be greater than 60. And now we simply follow our kind of three-step process. We'll simplify this side, so we'll distribute that 12. That'll give us 24x minus 36. That's got to be greater than 60. And then we'll isolate the x now by undoing these two operations. We'll start with the addition. Unless there's a grouping symbol that changes order, we'll start with addition subtraction. That cancels. So now I've got 24x is got to be greater than, and then on this side it's a 96. And then last but not least, we'll divide both sides to eliminate the 24. We'll divide both sides by 24, and that cancels the 24. It's a positive, so I don't have to worry about flipping an inequality because I divided by a positive number. But that does get x alone. It is still greater than, and then 96 divided by 24 is 4. So x must be 4 feet, or the possible values of x are greater than 4 feet, I should say, not 4 feet, but greater than. So the possible values of x that work here are any x value that is greater than 4 feet. Okay, and then our last one, number 13. It tells us here you need a mean score. So mean is average. That's another more academic word for average. Average is when we add up the points and divide by how many values we had. So it's how we calculate your grades and that sort of thing, right? So you need a mean score of at least 90 points to advance to the next round of the touchscreen trivia game. What score in the 5th game will allow you to advance? So it looks like we already know the scores for the first 4. We want to know, what does our 5th score need to be? So again, just to review, average or mean is calculated by finding the sum of all of your numbers and then dividing by how many there are. Okay, so in this case, I would want to find the sum of all of my games. Well, game 1 was 95, game 2 was 91, game 3 was 77, game 4 was 89, and we know that we're going to play a 5th game. So that's the one we don't know. That's the one that's our mystery value, right? So the sum of all 5 needs to be such that when I add them all up and divide by how many the games I play, which will be 5, I need that to be at least 90 points. So greater than or equal to 90. Okay, so the average of all 5 games. So I need to find out, well, I've already earned all these points. What do I need here? So that when I find the average of all 5 points, or sorry, all 5 games, they average out to at least 90. So this is going to be our setup. Okay, so first, step 1 is simplify. There's definitely a lot of math we can do because we can add all of this up together. So if we do 95 plus 91 plus 77 plus 89, and we simplify the part we can, which is this addition, all that stuff adds up to 352. So we've already earned 352 points here in the first 4 games. I want to know how many more points I need on that 5th one so that when I divide this by 5, this average is at least 90. Okay, so there's my inequality. Now, I said a moment ago, we typically get rid of the addition or subtraction first unless there's a grouping symbol that changes order. The division bar is a really good example of when that happens. When we have a division bar and we're dividing an entire quantity, that's kind of trapping this up here, right? I can't really tap into this until, while it's up here. I always think of it as kind of being up in an elevator and being trapped up there. And so I can't get in there until I get rid of this denominator. So having that long division bar, which acts as a grouping symbol and traps this or locks this in, makes me have to change that order. So now, instead of dividing the whole quantity by 5, I'm going to multiply. I'm actually start by undoing the division first. Normally, I would do that in my second step. But if there's a grouping symbol, that can change. So I'm going to actually multiply by this 5 on both sides because I know it'll cancel out that division. It'll get rid of that denominator. And now this will drop down, and it'll be free for me to tap into that and solve. So now I'll just have 352 plus x has to equal a total of 450 points. Okay? And then we can come here and get rid of and say, okay. So in other words, what I'm saying is this has to be at least 450 because when I divide it by 5, it needs to be 90. So I'm thinking, well, what's 90 times 5? That's 450 points. And now I'm like, all right, so that's what I need. I need at least 450 points. I already have 352. So what is missing? How many points am I missing here? Well, that's the difference between these, and it's exactly 98 points. So I need to score at least 98 points in the 5th game. That's the moral of the story. So the score must be at least 98 in that 5th game. There it is. And then I'll guarantee myself moving on to that next round. All right, multi-step inequalities.